Good morning, folks. It's Thursday, May 8th, and late morning, and I just thought I'd check in and do a little video. I haven't done many videos in a while, and it's mostly because I've been busy with other things, although I'm starting to get back into this A-frame project and make a little bit of progress. So I think the last video I might have done was the stairs, which was a fairly daunting project, and today I just got done with the outside of the wood stove piping, which proved to be a huge challenge compared to what I expected. So I'm going to just spin this camera back into normal mode so I can zoom in. If you look up to the upper right, I think, of what you're seeing, you'll see the stovepipe coming up through the roof. And that, I'm going to just talk about the exterior of that. The whole thing was a big project. I'll get into the interior another time because that's a whole nother can of worms. I'll probably walk in and just touch on it. But anyway, I'm going to switch over to the other way so you can see what I'm actually talking about. Okay, now we are turning around so we can see the A-frame. So anyway, yeah, it was a long winter. Took a while to get the snow to melt up here. We get a lot of extra weather up here than we do even at my house 5 minutes away. So the snow piled high, and it got here and closed me in before I was totally where I wanted to be with this little project. But over the winter, did a lot of skiing and hiking, and had a chance to go to beautiful Alaska for a week in the end of January for my birthday, but that proved to be quite cold but quite beautiful. So that ended up being a memorable, fun experience. And before I did that, I did get a chance to close this in with temporary windows made out of marine vinyl, which proved to be very valuable in terms of keeping the weather out. So anyway, to get into what I want to talk about. So if you look up there, you will see a stovepipe coming up out of the roof. And one of the big challenges in this project was simply the fact that I underestimated how difficult having this 64-degree angle was going to be when it came to trying to pass something through the roof. So this actually has taken up an inordinate amount of time, like, I don't know, maybe, I don't know if 100 hours. That might be a slight exaggeration, but all told, to get the entire pass-through built and put up. And then today I finally got up there and put the last sections of pipe up. And I was just a smidge short. I would have been done yesterday, but I am supposed to be at least 2 feet over the top of the ridge with the final pipe, and I was only a foot over it. So I was like, had to break down, run down to the store, and luckily they had hiding in the back room the last section of a 3-foot section of this stainless steel double wall pipe, which you need to use for the exterior. And there's a lot of things to do with wood stoves. I've learned a huge amount just doing this project. The wood stove sitting in the A-frame, but I never had it hooked up in time to use it in the winter, so had to do without it, which meant when it was really cold, it was just unreasonable to try to get much done. And then the snow was a constant thing that had to be plowed, so I did a lot with that. But anyway, to get into the nitty-gritty of this stovepipe install, so inside the roof is this big box that's about 6 feet tall that allows you to transition a 6-piece or a 6-inch black steel pipe that comes off the wood stove, and it's perfectly fine inside the house because it radiates heat, and you want heat in the house. And when you're in a house and it's throwing heat, it stays hot enough so it doesn't build up creosote. So the trick with wood stoves is you want to vent them well, and this venting project cost way more and took more time than the actual wood stove assembly and hookup did. And venting is enormously important because safety-wise, you don't want heat concentrating in places where it can start fires. And, you know, my wife had a tragic accident when she was a kid, and a certain amount of her family passed away in a fire. And it wasn't because of a wood stove, but it did, you know, it gives her and myself a respect for how fast a fire can destroy a piece of property and how fast it can spread. So anyway, the idea being absolute maximum safety was a goal with this. So they sell these pieces for a ceiling or a shallow pitched roof. It's not a big deal. You buy this box that allows you to transition the 6-inch steel single wall pipe. It goes into the bottom of that box, and then it has to go through the roof. And when it does, it transitions into a 6-inch interior stainless steel pipe with the outer walls. So the outer wall of this thing brings it to 10 inches in diameter on the outside. And while you're doing that, you have to have certain distances from things. And when it passes through framing, this passes through about 5 to 6 feet of vertical framing in order to make it up through the roof from where the point it exits in the building, which you'll see in a little bit. So what happens is we're looking at the outside. So this stainless pipe passes through the roof, and it has to be surrounded by another box, another layer of metal. So you end up with a triple wall situation. And where the pipe went through the roof, I had to put a steel plate on the roof with an ovalized hole in it, because the actual creation of the pieces and parts for this were a major part of the challenge, because I had to actually use AI. I used ChatGPT to help me determine the size and shape of the oval that would be required for the pipe to pass through the roof and leave 2 inches on either side outside of it for the metal box to be built. And the metal box is hidden inside. What you're seeing up here, you see stovepipe on the top. I'm going to zoom this up just so I can explain in better detail. Okay, so you can see, and safety-wise too, Al and I had this staging up so we could get the roof on here, which we did. So we just, a couple weeks ago, we got that green, if you'll look at the very ridge on the top, you'll see green metal. And that was something we had bent earlier in the winter and had on standby waiting for the weather to clear so we could install that. So that was actually a project to get that green metal up there and installed. And this is a pretty steep, it's about 24 feet off the deck, the floor deck, to get up to the top of this. And it's quite steep, so obviously we had to be pretty careful. And we had the staging on there from when we did the roof. That sat there all winter piling snow, and finally reached a point where I'm actually done with it now. Now that I got this done, this is the last remaining piece. So anyway, you've got this stovepipe, had to pass through the roof and then go up it goes up 4 feet above the ridge now, which is overkill. But the reason that you want it way above the ridge is so that not only so smoke won't land on your house and things like that, but what happens is when wind, especially in a place like this, like if you look down in the valley here, there's a deep valley there, and the winds will get fierce up here. They'll come flying up the valley, and when wind hits mountains, it typically will speed up to go over the mountain. So you get this effect in which, I forget what they call it, but the wind accelerates when it passes over a mountain, and then over a roof too, it will actually speed up even more. So you'll get a very strong updraft that will come up under that pipe. So if it's too close to the roof, then you can get this backdraft problem where wind will enter and come up under that pipe, and the pressure will drive the smoke back down the chimney, and it'll come out in the room. And I've had it happen. We've had wood stoves for years, and if things are plumbed right, that shouldn't happen. The cool thing with this, in this build, is that the wood stove being downstairs, there's a lot of pipe, so you get a good draft. You've got about, 15 or more feet of pipe before it even hits the roof, and then you've got another probably almost 8 feet sticking out of there. So there's a lot of pipe, and you get a good draft. So, and again, with these stoves, one reason for the double wall up there is you want to keep the pipe hot. So there's actually insulation between the layers in the pipe. There's an inner pipe with insulation around the outside of it, and then some airspace so that it breathes and air can pass up through that and stay hot. It'll breathe to keep the outside cool and the inside hot. And that's why there's insulation, so you won't build creosote that way. So if you run hot fires, you're going to keep less creosote building up in there, because the heat and the burn will keep the creosote down. If you have it too choked off, you can build up creosote, and that becomes a serious fire hazard. And I've seen plenty of chimney fires, and I've almost had them myself. So when the thing doesn't draw right, it's good to inspect it. And if you see a bunch of creosote building up, then you get it cleaned, or if you have the brush, you can take the top off and brush that chimney out to keep it clean. And then there's an old tale that I thought was some kind of joke that I looked into, but I would have old redneck kind of people say, oh, you just throw some beer cans in there every so often, aluminum beer cans, and they'll burn the creosote out of there. I'm like, well, that's kind of cool. So I actually looked that up online earlier this winter, and sure enough, the aluminum in beer cans and most products have some manganese mixed in with the aluminum. Don't ask me why, but chemically speaking, the manganese sounds like magnesium. It's manganese that's actually the metal that's in there. And when the aluminum cans burn and melt and disappear, they give off the manganese, and the manganese reacts with the creosote, and it causes it to burn up and go away. So if you do that on a consistent basis, you can really cut down on the amount of creosote in there. I started doing it. I thought it was ridiculous at first, but it actually is a thing with some scientific basis. So anyway, little hint to throw out there. So anyway, to get more into this box thing, so where the pipe came through the roof, so we had this box that's in the house that allowed us to extend. We basically took a transition box built for like a 612, which is a shallow pitch, and we extended it and then bent metal and cut it so that the top end of it was at a 64. So we basically added a big section to build it up so that it would pass through this roof. And then on the top of the roof, there's a metal sheet of galvanized steel with an ovalized hole in it laying on the roof. There's one on the inside where the box inside meets the roof. There's one on the outside on top of the roof. And then probably the biggest project of this whole thing as far as getting this built was, I'll expand this a little bit. So to get an aluminum flashing, or rather a galvanized steel flashing that would fit over the pipe to keep water out, was also a trick, because I could not find one anywhere online that I could order, and to have one fabricated would have cost, like literally they wanted at least $700 or $800 to do ones at a lower pitch than this. But I was able to find one online to fit a 12-12 pitch, which is a 45-degree angle. This is 64. So I was struggling to figure out how I was going to use this thing, and I realized at one point I put it up there hoping there'd be enough slack in it to make it work, but obviously when I got it up there, the angle was wrong, it did not work. And now I'm zooming in on the bottom of this. So what I ended up having to do, and I used AI on this one too, is I realized I had a flashing that has the cone above it that the pipe passes through, and then that was designed for a 12-12 pitch, but it wouldn't work. So then I'm like, tearing my hair out, literally trying to figure out how I was going to create something that would work for this without paying somebody else to fabricate it. And then all of a sudden one day I had this little brainstorm. I'm like, wait a minute, there's a difference. 64 degrees versus 45 is 19 degrees. If I could make an adapter of some sort that would allow me to use the existing one that I'd already bought and paid for and make it work by extending the bottom of it, I could maybe get this to work. So that was interesting. I actually got on ChatGPT and I had the angles, but I didn't have the lengths of the sides of these triangles. And then you'll see a front piece with kind of an X across it, which is something my brother knew to do when you're bending metal. That kind of takes some of the tension out of it. It stiffens it in a way too. It makes it less likely to just bend up. So anyway, ChatGPT gave me the dimensions of the side triangles and that piece that's on the front with the X on it. And I was able to sit down and make it out of cardboard. And then Al came up one day and he'd gotten me a sheet of galvanized metal, and we actually cut all the pieces. So there's two triangles on the sides, the front piece, and then a bottom plate. And we managed to take the piece that I'd purchased and the one with the cone that was designed to sit at the 12-12, and we added and riveted on this adapter, and of course sealed everything with heat resistant caulking and built the adapter that you're now seeing. So the adapter piece is the piece with the X on it that goes under the cone piece above it, but it actually worked. It came out perfectly, and we're able to install it up on this. So now we have what I consider a completely safe pass-through. That's a box that surrounds the stovepipe as it passes through the roof, flashes it to the pipe, and that's sealed with some heat-resistant caulking. So the whole assembly now on the top is finished, and then the stovepipe is a good product. It links together. You turn it and it clicks on, and you just link these pieces together. And then the other thing I'll point out, so there's a chimney cap on this that allows the breathing of the pipe. There's a double wall, so there's an air space between the inner pipe and the outer pipe, and the air can actually pass up through and exit under the bottom of this cap. And then the cap has, of course, screening, and then of course the top is a stainless, more or less a disc that allows the rain to hit it, and nothing can actually get in it from the top. Smoke can get out, but nothing can get in. So that device descends down into this assembly, and then that exits from the house itself. Now I'm going to take a minute. I'll walk in. The house is a mess. I've been doing a lot of different things, but no matter. I'm going to go in and give you a brief overview of the inside while we're on a roll here, and then I'll show you a box that represents the product. All right, we're just going in the front door. I'll zoom back out a little bit, and you'll see the mess I got in here. I got a terrific amount of insulation. Oh, here's the box. I'm not advertising products, but I know this is a good product, and I will say, got this at Tractor Supply. So this is Duravent, and let's see. So this is a 6-inch pipe on the inside, 36 length, and a good product. Stainless steel. These things are pretty expensive. They're about $150 a piece for a 3-foot section, of which I think I'm 1, 2, 3, 4, I think I used. So as we come in here, now we're inside and we're down below where the stove assembly is. And I will go over here. I'm sort of at the bottom of my stairs, starting to frame in the upstairs now. I had my son Carter up here helping me yesterday. So we're framing in the bathroom walls, and I even built a little ladder. I'll take a walk up here just to let you see it for fun. Oh yeah, and then these crazy stairs, they were a fun project. I don't know why I'm taking all these projects that are a little bit complicated. So yeah, this is my little 3rd floor loft, and then the bathroom is going to be under it. And I built a little ladder for access there, and we will turn around. Actually, it's not a bad angle to see this from. So I ended up having to make a correction. When I went to build this staircase, excuse me, I realized I didn't want it taking up the whole room, so I angled it in off the bottom. And that was another project that took a little bit of thinking to figure out the angles. So staircase would come up and come in and maintain the necessary headroom. I think I went into that in another video about stairs, so I won't reiterate that. But I did end up cutting back my 6-foot balcony to 4 feet because I realized I wasn't going to have room for the stairs to run out, and I kind of like the way they landed right near the window, which is cool. It's kind of a coincidence, but it worked. And so anyway, we'll look at this top box. So this is where the wood stove, you can see the wood stove is down here. Hasn't been installed completely yet because we didn't have anything to connect it to. Now we're going to look up, and like this box, it's actually the bottom end of what you were seeing on the outside with the stovepipe coming up. And so I bought this piece you can see a line of rivets about 1 foot up. So 6-inch pipe will go into that bottom piece, and then there's a transition metal piece that converts that over to the 10-inch diameter stainless. So as it passes up through that cavity, right at the bottom, it has to stick down about 4 inches, which it does. That the first stainless piece comes down through all the way through the framing, and then it joins onto that bottom piece, probably 6 inches in. There's a piece that it connects to that allows the heat to be transmitted up into the upper pipe, but it breathes. It allows a certain amount of air to go up through next to it and take the heat out with it. So, that whole thing can do what it's supposed to do. But anyway, this box, you can see where the rivets are on the bottom run. Everything else above that is green metal, similar to what we had it left from the ridge cap, actually. But again, most of this won't be seen. You'll see what sticks out beyond the framing, minus the sheetrock and some furring that'll eventually be there. So that gizmo took a considerable amount of time to think out and build, but we did. Al had his access to a bending brake in a business of some friends of his, so we were able to go over there and make the pieces to assemble this box. So we screwed and riveted it together and then installed that up into the framing, and then from the top side we obviously did the piping in the upper piece. So this was a bit of a trick. So there's been a lot of hours have gone into this project, both the inside and the outside, and now what remains is not that difficult. I've got to just send some pipe down, and I've got to find some ways to suspend it. It's going to come down, and then it's got to take an angle. When it gets in over this area where the door, right now the door is not here yet. The door is temporarily plywood. There'll be a nice French door there eventually, hopefully soon. So anyway, the pipe's going to come down, and when it reaches that header above the doors, it'll kick over a couple of feet, and then it'll drop down to the wood stove and connect up. So that all that remains of this project at this point is just to drop the 6-inch pipe down and get that hooked into the stove and suspended in such a way it's supported adequately. And then eventually, one fine day, I am going to take cement board and tile and create a nice little hearth there, because that's another safety issue near a wood stove where the door opens, embers and debris can fall out of it. So the insurance companies require, and it's a simple smartness to do it, is to put cement board on the floor several feet out in all directions, and then I'm going to tile a nice little hearth. So that'll make it safe. And it's buried now. I got some wood in the back there. But anyway, it'd be a nice area for some wood to be stored in that corner. And that will be happy. So this coming winter, I hope to have that fully functional and working. And so for now, yeah, we're getting things done. We're getting the stairs done. We're getting in here to get some framing done. So we're going to have a nice little bathroom in here. Luckily, things are working out. This has sort of been a plan and design as you go build. And knock on wood so far. I mean, I've had to fix a few mistakes here and there. I hate working backward, but I began to realize if you want to end up with the right thing in the end, you don't start out knowing everything. And until you actually see things physically, it's very hard to visualize them adequately to make all the decisions you got to make. So this is one of those projects that when it's completely done, then I'll draw up the plans and maybe offer them for sale to other people that want to start from the other end with actually some idea what they're doing. I mean, I have a lot of carpentry experience over the years, but doing an A-frame was a completely new and different experience, but it's definitely enjoyable. It's challenging. It's a little frustrating at times, but so far so good. I'm really enjoying the way it's coming out. We got these little dormers. We got a little skylight up there. We got a nice open end. And I'm actually really glad of one bit of advice that I took is somebody was saying when you're building an A-frame or a high triangle like this, and you want to keep the summer sun out and the winter sun in, what you want to do is extend an overhang out beyond it. And I looked into that, and that was another logistical little bit of a nightmare as far as figuring out how to construct this. But one of the big benefits of having that big overhang out there is not only does it keep the sun out when it gets hot, the sun, when it's overhead at a high angle, it doesn't come in. In the winter, it's at a low angle. It'll come right in and warm this place up and light it up nicely. So that's a benefit. But the other thing is, I don't have those boards off right now, but I have staging out there, and I left it there, and I have some boards across it at about the right working height. So the nice thing is I can take those plywood pieces off, and I have an immediate workbench right out there, and it can rain like hell, and none of it, very little of it, unless it's seriously windblown, will actually reach the door. So it'll actually, that overhang is protective. Even in the winter, there would be most of that little deck would be clear and easy to clear off, and the sun would come in at a low angle. So anyway, that was another thing. It was a bit of advice I took from somebody, but the framing of that overhang to get that 8 feet out at the top and only 2 feet at the bottom really took some thinking and extra reinforcing, because structurally that's a little dicey because you're still carrying weight out there. You've just got to find a way to angle it back in where it'll be carried. Anyway, that's about as much as I wanted to say today, probably a little more actually. Hope you found it interesting, and if you ever take on a project like this, all I can say is I hope you find this interesting. Steep angles are definitely complicated, and if I paid somebody else to do what I did on this thing, it would have been thousands of dollars more than the time I spent, and it's probably a little easily into $1,000 just in materials for between the piping, the flashings, and that transition piece, and various other miscellaneous things. And one small thing I don't know if I mentioned, I think I forgot to when I was out there, was on the outside. If you have something, a stovepipe extending more than, say, 4 feet over the roof, they recommend putting some bracing in there. And up here, the winds are fierce in the winter, and I'm like, yeah, I'm definitely doing that. So what they recommended, and I did, was to buy conduit. I think it was basically 1 inch or 3/4 inch galvanized conduit, and that stuff was heavy. You have to hammer the ends flat, and then you drill holes to connect it, and then you got to bend it a little bit. But I had to beat the crap out of that with a hammer to flatten the ends, and I had to flatten one end and go up there and sort of temporarily attach it to the pipe where there's a kind of a brace, a two-piece brace that wraps around the upper pipe. I connected to that, and I figured out where I wanted to lay it on the roof. So I had to connect in on the ridge metal where it was thick to give an extra layer and some more support, and then you drill and screw it in. Of course, I brought a 2-foot level up there and put it on the pipe to make sure I was plumb in both directions. So before I fastened it, I connected the ends that connected to the pipe, and then the other ends I just positioned them with it level, made marks with the magic markers, so I knew when I put the lag bolts into the roof that it would lock it in the correct position, and that triangulated it. You had the pipe coming up out of the roof, and then you have 2 legs going out that actually connect that. So I know you can't see that now because that's on the outside, but you can visualize it. So there's 2 pieces of conduit that come off that main pipe pretty high up and tie into the roof. So that creates bracing. It kind of triangulates it so the fierce winds will not be able to move that. If they did move that, it would break the caulking between the stovepipe and the flashing, and then eventually water would get in. So I'm taking every precaution, because once that staging comes down, I'm not going to want to have to put ladders up and climb up there and monkey with it. So I made sure every connection was secure and watertight. And with a little bit of luck, that will give many years of good service and keep this place pretty cozy. I will have some other backup heat. The wood is usually actually the backup heat, but I like it because when you have a wood stove and a pile of firewood, you don't need electricity, you don't need internet, you don't need any of these modernized gadgets. I actually love my old wood stove at my house because it's foolproof, virtually. There's nothing that go wrong with it. The light, it doesn't require, like I said, internet or electricity or anything. You open it, you build a little fire with some wood, you light it up, and bam. It's nice to have something very crude and simple and primitive that's backup, because then it works under almost any conditions. But eventually I may end up with some mini splits, or I've been toying with different methods up here. Where it's this cold, mini splits aren't necessarily the best thing, and other heating systems, oil is reliable generally. But anyway, I'm getting off into another subject, so I'll stay away from that. But this is my backup heat, and probably something I'll use quite a bit because I love wood heat. It's just a nice feel to it. It's cozy, and it belongs in a cabin. Anyway, good talking to you folks. Hope you found this interesting, and tune in next time when I make some more progress. I will check in again. At this point in the year, we're starting to get up to speed, so a lot will be happening up here. Enjoy the day. Take care.